So yesterday we talked about the first type of our sampling, or the first of our sampling methods, which was an SRS. It's kind of the most basic, but probably the most important method of sampling that we cover because it is utilized in every form of good sampling that we discuss. And so over the next couple of days, we're going to be talking about a bunch of different sampling methods as we talk about how to collect our data correctly. So when we want to get this information that we can then use and analyze for a population, how do we get that information correctly? And so we started with an SRS, which was we take the entire group of individuals we're selecting from, assign them labels, making sure all the labels have the same number of digits. We generate a random number using a calculator or a table of random digits, and then we collect our sample accordingly. And so for that, we're just basically putting everybody into a pool, giving everybody an equal likelihood of being selected, as well as every possible sample being selected as well. So the problem is we're going to run into scenarios like this first example here, where an SRS is not necessarily sufficient to create or guarantee that we have a representative sample selected. So as we look at this example here, it says we want to learn how students feel about funding for the football team at a large university. We know the campus is made up of 60% men, 40% women, and we do suspect that men and women will have different views on this funding. So if we take an SRS of 100 people, we should have a few concerns about the sampling choice, because while we would be giving everybody an equal likelihood of being selected, we know ahead of time that we have a subgroup, where we have subgroups within our population that are probably going to have differing views. Now, the way an SRS would be carried out is I would label all of my students. I would generate my random sample using my calculator or table of random digits, and then I would collect that group of individuals and ask or find out the information. But the problem is with the SRS, while it most likely will give us a sample that results in somewhat of a representative group of individuals, we won't guarantee it. So for instance, if I were to do an SRS from this university, I could get a sample of all men. So since everybody has an equal likelihood of being selected, when I go to select my sample, I could get all men, I could get all women. And if either of those scenarios happened, then I wouldn't be getting a representative look at the entire population of students. And so that SRS, while it's nice to use and it's one of our better options in most instances, won't suffice in a situation like this, because we want to guarantee that we have some men and some women in our sample to be representative of the entire population, and an SRS can't guarantee that. So we're going to use a different method of sampling called stratified random sampling. And so basically what's going to happen is we're going to break our population up into different strata where there are groups of similar individuals. So meaning I separate into subgroup 1, and every individual in subgroup 1 should be the same according to some defining characteristic. Like in our last example, I'm going to separate into one subgroup of men and a second subgroup of women. So they differ based on that characteristic there. So within group 1, I've got all men. Within group 2, I've got all women. So strata can be created based on any number of factors. So it's a defining characteristic that we identify before we select the sample that we want to separate our population into. And then once I have my strata set up, so once I have group 1, which is all the same on the inside, but completely different than group 2, which is all the same on the inside, but different from group 1, then what I want to do is I want to select a sample from each of those groups. So for instance, on the example there on the screen, if I wanted to select a sample from a high school, so a study about sleep habits, students at a high school, the population could be divided up by grade level. We might feel like 9th graders, 10th graders, 11th graders, 12th graders have differing views on what we're going to be measuring. And so I want to make sure that when I collect my sample, I get a group of freshmen, I get a group of sophomores, and so on. So as you can see then, I start with my population of all students, but then I separate into these 4 strata. So I'm going to do all my 9th graders in a group, all my 10th graders in a group, and so on. And then from there, I'm going to take an SRS from each of those groups. So here's where we're using that simple random sample again. So even though we're not using the SRS directly, we're still going to employ it at some point within our setting. And that's, like I said, the case that's going to be with all of our good sampling methods. We're going to be using an SRS at some point. So now in this case, I'm going to end up with a sample where I have some 9th graders, some 10th graders, some 11th graders, and some 12th graders included. So now my actual sample should be fairly representative of the entire student population. So that's kind of what we're going for with this stratified sampling, is we identify these characteristics ahead of time that we think are going to cause differences in the response variable. So we separate our population into those subgroups, and then we use those subgroups to select some of the individuals from each using an SRS. When we choose our strata, like I just mentioned, it's based on facts that we know before the study. We want individuals within each strata to be similar to one another, but we want one group to the other group to be completely different. So it's internally all the same types of individuals based on whatever defining characteristic we identify. Group 2, individuals that are the same based on the defining characteristic, but group 1 and group 2 are different from one another. And then we take a sample from group 1, we take a sample from group 2, and we put them together and analyze the results. So going back to that original example then, knowing that we think men and women are going to differ on their opinion on funding, if I want to select an SRS of 100 people, we do not want to do an SRS because while it could give us a representative sample like we hope, it can't guarantee that we're going to get what we need in order to answer this question correctly. So when we improve our sampling, we're going to use this stratification process. So we're going to separate the group of students at the school into men and women. And then not only that, when I separate into those two different groups, I want to try to match the population as much as possible. So normally, if we don't know anything about the overall population in general, we would take 50 men, we would take 50 women, generated randomly using that SRS, and we'd collect our 100 individuals and measure our response. But in this particular instance, we can even be more specific. Since they said we have 60% men and 40% women in the population, once I separate into my two strata, for the men, I'm going to take a simple random sample of 60. I'm going to take from the women a simple random sample of 40, and I'm going to take those two groups and combine them to make my 100 individuals for my sample. And then that guarantees not only do I have men and women included, but I have the same breakdown of men and women as I would expect in the total population. So that stratified sample should be much more representative of what I expect in the population compared to what an SRS might come up with. So this stratified sampling occurs when we have concerns that the SRS we're going to start with doesn't quite do what we need it to, or can't guarantee that we're going to get what we need out of it. And then as far as this stratification process goes, again, some of the important benefits: it reduces the variability for our results. So we talked about yesterday that sampling variability. Anytime we employ randomization in our process, we're going to get different samples from one iteration to the other. So if I take a random sample of individuals and I measure a response, and then I go back and I collect a different random sample from that group of or my population, I'm probably going to get different responses for each of the different groups that I create, because one group is probably going to be different than the other based on that random selection process. When we restrict by strata, we're reducing the variability between the groups that I select. So in this men versus women, I select 60 men, 40 women. If I were to do that same process again, I'm still going to get some sampling variability. I'm still going to get different results each time, but I'm going to get less different results than if I just simply threw all the students into a pool and randomly selected, because I could get some samples in that situation that are more like way more men than women, way more women than men, all women. So my sampling variability is going to be much larger in an SRS. Whereas by breaking the population down into subgroups and selecting from those subgroups, I'm going to reduce that variability from one sample to the next. Stratified also reduces bias. So we're going to talk about bias next week, but what we're looking at is if I took an SRS of that student population from our example in the notes, if I got a sample of all men, that means I'm missing an entire group of my population that I feel has a different opinion on the response variable. So that's going to result in what we call undercoverage. That's a source of bias. So by stratifying, I eliminate that source of bias because now I've guaranteed that my sample is going to be more representative. And then it can also even help us notice important differences amongst the groups. So since I'm selecting from these different subgroups we think have differences, we can actually analyze those differences from group to group based on the responses that we get. And so with that, you guys should be able to complete the assignment for today. And then we're going to get into, like I said, some more sampling methods next week, as well as some of the forms of bias that we could be looking into as well.